Hello everyone. In this class we will see the new concept of your modulo numerical methods, that is numerical solution of polynomial and transcendental equation. Given an equation f of x is equal to 0, it is generally not possible to find roots of x such that f of x becomes 0 exactly. If f of x is equal to 0, we generally this is not possible to find the values of roots of x. We discussed two numerical methods to find approximate real roots of the given equation. Here we have two numerical methods to find the approximate root, not exact, approximate real root of the given equation. Equations involving algebraic quantities like x, x square, x cube and etc. are called as polynomial or algebraic equations. Means an expression which is having the algebraic quantities like x, x square, x cube and so on. That expression is called polynomial or algebraic equation. These are the examples. Next is equations that involves non-algebraic quantities like e raised to x, log x, sin x, tan x and etc. are called as transcendental equation. Here we have to find the numerical solution of polynomial and transcendental equation. This is the definition of polynomial and this is the definition of transcendental equation. An equation having algebraic quantities is called polynomial or algebraic equation. An equation having non-algebraic quantities like e raised to x, log x, sin x and tan x and so on are called as transcendental equation. These are the examples. Next, if f of x is equal to 0 is a real valued continuous function of the real variable x, we have the following fundamental property. Means if our given equation is of the form f of x is equal to 0 is a real valued continuous function of the real variable x, we have to apply the this below fundamental property to find the solution. What is that property? If there exist two values a comma b such that f of x has a opposite signs. F of x has a opposite signs. Say f of a is less than 0, f of b is greater than 0. That means one value is negative, one value is positive. Equivalently, f of a into f of b is less than 0. Then there always exists at least one real root in the interval, that is a comma b. Means our given function f of x is equal to 0 is a real valued function of real variable x. We have to apply this fundamental property where a and b are the two values where f of x has opposite signs, means f of a is a negative, f of b is a positive. Then there exists at least one root in the interval, that is a comma b. In this interval we get at least one root. This property is useful in locating an initial approximation for a real root of f of x is equal to 0. This property is useful for what? For locating an initial approximation for a real root of f of x is equal to 0. As I already said, we have two numerical methods. First one is regular falsie method or method of false position. Here the derivation is not required, you just remember the formula. The formula to find the first approximation xn to the real root lying in the interval a comma b is as follows. x1 is equal to a into f of b minus b into f of a whole divided by f of b minus f of a. This is the formula for to find the first approximation. Okay, the process is continued till we get the consistency in two consecutive approximations. You already know what is the meaning of consistency in two consecutive approximations. Means the consecutive values of x are approximately the same. Here we don't have the working procedure. Just go for the first example. I will solve in detail. You will know what is the procedure of this method, that is regular falsie method. First example, find a real root of the equation x cube minus 2x minus 5 is equal to 0 correct to 3 decimal places. 3 decimal places means we have to find the consistency up to the 3 digits after the decimal point. This is the meaning, correct to 3 decimal places. Solution, let f of x is equal to x cube minus 2x minus 5. See here our f of x is equal to 0, which is a real valued function in real variable x. We have to use that fundamental property. According to that, we will get 2 roots where f of x values are, one is positive, one is negative, so that we have to find the f of a and f of b value where one is less than 0 and one is greater than 0. For that, substitute the values of x from 0. I will get f of 0 is equal to, substitute 0, what we will get, it will be minus 5. Okay, f of 1 is equal to minus, see f of 1 cube minus 2 minus 1 cube is 1, minus 2 into 1 is minus 2, 1 minus 2 minus 5 means minus 7 plus 1 is minus 6. F of 2 is equal to 2 cube is 8, 8 into 8 minus 4 is 4, 4 minus 1 is minus 4 minus 5 is minus 1, and f of 3 is equal to 3 cube is 27 minus 6 minus 5, we get it as a 16. See, continuously we get the negative values, and the fourth one is our positive value. We get the positive value after the negative value. We have to consider these two values because consecutive terms are giving, one is less than 0, one is greater than 0. See, this is less than 0, this is greater than 0. For consecutive values, consecutive means for continuous values, we get one is less than 0, one is greater than 0 as the functional value, so that our root lies between what, 2 and 3. Here f of a is less than 0, f of b is greater than 0. Like this you have to find the value of a and the value of b. Therefore, a real root lies in the interval a comma b means 2 comma 3. Since a is equal to 2, b is equal to 3. Next, now it may be observed that the value of f of x at x is equal to 2 being minus 1 is nearer to 0 compared to f of 3, which is equal to 16, and we expect the root in the neighborhood of of 2. We shall the interval a comma b for applying the method such that b minus a is small enough. Okay. This is not necessary to write, but since this is a first example, for your better understanding I have written everything. From next example we go directly. From that property we know that we get an interval a comma b, and equivalently we have f of a into f of b is less than 0, means the difference of this is small enough. Then there always exists at least one real root in the interval a comma b. Here we get one real root between these two. For that, what we have to do here, see whether f of 2 value is near to 0 or f of 3 value is near to 0. From the observation what we get, it may be observed that the value of f of x at x is equal to 2 being minus 1 is nearer to 0 as compared to f of 3 which is equal to 16, and we expect the root in the neighborhood of 2. Since the value x is equal to 2 being a minus 1, we accept that the root is near to 2. We shall have an interval a comma b for applying the method such that b minus a is small enough. Here f of a and from the property f of a into f of b is less than 0. That means b minus a should be small enough. For that we will take the roots which is near to 0, because when x value is 2, we get f of x is equal to minus 1 which is near to 0. This is how we have to consider the values of a and b. This is the first step to find the value of b, a and b. After that, to get the small enough values, means to satisfy the f of a into f of b is less than 0 condition, we get a further step, that is see whether f of a value is near to 0 or f of b value is near to 0. Whichever the value is near to 0, try to get the values of a and b from that value. Okay. Now we are taking 2 here. After 2, what we will get? F of 2.1. Substitute 2.1 in the given equation, that is f of x is equal to x cube minus 2x minus 5. Substitute x as a 2.1. What we will get? 2.1 whole cube minus 2 into 2.1 minus 5. After calculation we get 0.061 is greater than 0. See, this value here we have positive value, means this is greater than 0. Therefore the root lies in 2, 2.1. See, when f of x value is 2, f of x value is minus, means which is less than 0, and when x value is equal to 2.1, we get f of x as a positive value, means which is greater than 0. See here, f of a, this one is less than 0, f of b is greater than 0. When we get f of a into f of b, we will get which is less than 0, and here b minus a value is very small enough. See, when we consider b minus a, means 3 minus 2, the value is 1, right? When we take a as a 2, b as a 2.1, we get 2.1 minus 2 is 0.1. as compared to 1. 0.1 is very small enough, so that we have to consider the interval as 2, 2.1. See, if you get this value is negative, means 2.1 value is negative, then further go for UF of 2.2. Since in this example I got the direct 2.1 value is a positive, so not necessary to go for the further values. If in the next example, if you got next is a negative value, here also we have a negative value, here it is a negative value, so that further go for f of 2.2. if f of 2.2 value is a negative value, then take this as a, means 2.1 as a and 2.2 as a b. Okay, for this example our root lies in what? 2, 2.1. Here we have step by step methods. First step, from regular falsie method we know what will be the formula of finding first approximation. Before that, a value is 2 and f of a value is what? Minus 1. That is f of a is equal to f of 2, a value is 2 and b is equal to what? 2.1. f of 2.1 is equal to how much? 0.061, which is equal to f of b. Now from the regular falsie method, formula for first approximation is x1 is equal to a into f of b minus b into f of a whole divided by f of b minus f of a, which is equal to a value is 2, f of b value is 0.061 minus b value is 2.1, f of a value is minus 1 whole divided by f of b is 0.061 minus f of a is minus 1. Calculate this one, simplify this and calculate. What we will get is x1 is equal to 2.0942. This is what? This is first approximation. I will write in short, first approximation. x1 is equal to 2.0942. This is the first approximation. Next we have to find x2 for the second approximation, because we have to continue this process to get the desired accuracy in two consecutive approximation. Before going to the second approximation, again we have to find the value of a and b, and now consider this as a x value. Second step, step 2, then f of 2.0942. now substitute x value as a 2.0942. what we will get? 2.0942 whole cube minus 2 into 2.0942 minus 5. Calculate this one, we get minus 0.00392. See, which is less than 0, because we have a negative value here, 2.0942. See, this is a negative value, means less than 0. Less than 0 means this is the value of f of a, means value of a is what? 2.0942 and f of a value is minus 0.00392. Therefore, this is the value of f of a. So that for the next step, means second step, our a value, therefore here our root lies between, roots lies in 2.0942 comma 2.9. means when we continue this process, we get b minus a value is very small enough. Okay, now here our a value is what? A is equal to 2.0942 and f of a value is minus 0.003942. Here we are having negative values, so that I am taking this as a f of a value. If you get positive value, take it as a f of b value. Okay, this depends upon our given function, given example, and b is the same. B is equal to 2.9 and f of b is equal to 0.061. Next, our second approximation value, same. x2 is equal to a into f of b, b into f of a. Formula is same, but the values are changing here. F of b minus f of a is equal to a is 2.0942, f of b is 0.061 minus b is 2.1, f of a is minus 0.00392 whole divided by f of b value is 0.061 minus f of a value is minus 0.00392. Simplify this one, we get it as 2.09455. This is what x2. Here condition is what? We have to find the answer up to, find the real root of the equation correct to 3 decimal places. Means we have to check whether the three digits are same after the decimal point or not. See, x1 is 2.0094 and here x2 is 2.094. Means up to 3 decimal places we get the same answer. So that x1 and x2 are close enough x2 is a better approximation than x1. Thus, the required approximate root correct to 3 decimal places, is 2.095. Okay, this is the procedure. If you don't get the 3 decimal places are same in the second approximation, next go for the third approximation. Before going that, what we have to do, consider this as a x value, find f of 2.0945, see whether this is a positive value or negative value. Okay, next go for the same procedure. Second example, we shall compute the real root of x log x to the base 10 minus 1.2 is equal to 0 by correct to the 4 decimal places. 4 decimals means 4 decimal places. The given function is f of x is equal to x log x to the base 10 minus 1.2. Now same as the previous example, let us go for the smallest one. Here we get f of 0 and f of 1 value as the same, so that I am taking directly f of 1 is equal to what? F of 1 is minus 1 by 2, because log 1 to the base 10 is 0, 1 into 0 is 0, minus 1.2 is minus 1.2. Now f of 2, see when you are calculating this, change your Falsie function by log base to the a to log to the base 10. Then only you will get the correct answer. If you are Falsie having log to the base e, you will get the different answer for log 2. If it is log to the base 10, you will get f of 2 as a minus 0.2. Okay. Then f of 3 as a 0.23. Here this is less than 0, greater than 0. Means we get f of the condition f of a is less than 0, f of b is greater than 0. Here that means our real root lies between 2, 3. Okay. And here b minus a value is 1. Now we try to find the b minus a value is small enough, right? And from the value of f of x at x is equal to 2, 3, we expect the roots in neighborhood of 3, because 0.23 is near to 0 as compared to minus 0.6, so that we expect the root from the neighborhood of 3. And let us find a, b for applying the method such that b minus a is small enough. For that, our next here the value is what? The positive value comes at x is equal to 3, right? The negative value is at minus 0.6. This is positive value, means we get the two consecutive values are negative and positive. See, when we go for 3.1, again we get a positive value only. So that to get a negative value, we go for the value x value which is less than 3. So that find f of 2.9. You will get what? Positive value. Okay. And go for 2.8. Calculate this one. Calculate yourself. F of 2.8, we will get it as 0.052, which is what? Greater than 0. And when you find f of 2.7, you will get minus 0.0353, which is less than 0. See here, two consecutive values. Two consecutive values are giving one is greater than 0, one is less than 0. But in a previous example, we get the two consecutive values. That is 2 is a negative value, 2.1 is a positive value. So that in that example, not necessary to go for the further terms. But here, for at 3 we get, at x is equal to 3 we get a positive value, right? And when at x is equal to 2.7 we get a negative value. Here we are not taking a as a 2.7 and b as a 3. Why? Because when we take the difference 3 minus 2.7, what we get? We get a 0.3. Difference is 0.3. But when you take the difference of, means b minus a, b is 2.8 and a is 2.7, what you get? 2.8 minus 2.7, what we get? It has 0.1. 0.1 is small enough as compared to 0.3. So that we have to consider the value of a and value of b in such a way that we get b minus a is very small enough, right? So that we have to take a as a 2.7 and b as a 2.8. Okay. Next, the roots. Therefore, the roots lies in 2.7 and 2.8. The value which gives less than 0, that is the value of a, and the functional value which gives the greater than 0 value, that is the value of b. First step or first iteration, you may take anything. First step, a is equal to 2.7. You must specify all these values before going to the formula, not directly substitute the values. F of b is equal to 0.052. Now the formula x1 is equal to a into f of b minus b into f of a divided by f of b minus f of a, which will be equal to 2.7 and f of b value is 0.052 minus b value is 2.8. F of a value is how much? This is minus 0.0353 whole divided by f of b value is 0.052 minus f of a value is minus 0.0353. Calculate this, we get 2.7404. This is what? X1. This is first approximation. Next is second step. Here what we get? We have to find the f of 2.7404. We get it as a minus 0.00021, which is less than 0. Right? Here we get the negative value, means this is the value of a. A value is 2.7404 and f of a value is minus 0.0021. Therefore, the root lies in 2.7404, 2.8. Therefore, a is equal to 2.7040 and f of a is equal to minus 0.00021. B value is same, that is 2.8. F of b value is same, that is 0.052. x2 is equal to, write the formula, a into f of b minus b into f of a divided by f of b minus f of a, which is equal to, here the a value is what? A value is 2.7404 and f of b value is 0.052 minus b is 2.8. F of a value is 2.7. Sorry. Here f of b value is correct. A value is this. F of a value is minus 0.0001 whole divided by 0.052 minus of minus 0.3 times 0 to 1. Calculate this, we get 2.7406. See, x2 and x1 are not the same up to 4 decimal places, because x1 value is how much? 2.7404. Here we have 2.7406. So that we go for the further steps. Third step. Next we have to find the f of 2.7406. We get minus 0.4 times 0.4, which is less than 0. So that this is negative value. Therefore, it will be the value of f of a. Therefore, the roots lies in 2.7406, 2.8. Now a is equal to how much? 2.7406. F of a is equal to minus 0.4 times 0, 4, and b is equal to 2.8. F of b is equal to 0.052 as it is. Now substitute the values. x3 is equal to a into f of b minus b into f of a divided by f of b minus f of a. Substitute f of a, f of b and b into f of a. Here b, f of b minus f of a, and calculate. You will get x3 as 2.740646. See, our f2 is what? x2 is 2.7406, x3 is 2.7406. Here we have to get the desired accuracy up to 4th decimal places. Means after the decimal point, 4 digits are same. So that thus the required solution, required approximate root correct to 4 decimal places is 2.7406. This is the method of solving the examples using regular Falsie method. Here you have 2 homework examples. Compute the 4th root of 12 correct to 3 decimal places. Here they are not given the function f of x. You have to write the function f of x on the basis of this sentence, that is compute the 4th root of 12 correct to 3 decimal places. How you write the 4th root of 12 here? 4th root of 12 can be written as square root of 4th root of 12. This is how you have to write this 4th root of 12. Right here the value of x is what here? Square root of 4th, x is equal to 4th root of 12. Therefore x raised to 4. Raise the power on both the side raised to 4. You will get x raised to 4 is equal to 12, or x raised to 4 minus 12 is equal to 0, which implies our f of x is equal to what? X raised to 4 minus 12. They will give any number in place of 12. 4th root of 12 can be written as like this: 4th root of 12, x is equal to 4th root of 12. Here raise the power 4 on both the sides. X raised to 4 is equal to 12. X raised to 4 minus 12 is equal to 0. Therefore f of x is equal to what? X raised to 4 minus 12. This is your function, and remaining steps are same. Go find the f a and b first, then go for the a and b which gives b minus a is very small enough. Okay, next find the real root of the equation cos x is equal to 3x minus 1 correct to 3 decimal places. Here they are given in a different form, that is cos x is equal to 3x minus 1, which can be written as what? Cos x minus 3x minus 1 is equal to 0. Sorry, this is minus, means it will be, here it is plus. This can be written as cos x minus 3x plus 1 is equal to 0. Therefore, which implies f of x is equal to what? Cos x, I will write positive term first, cos x plus 1 minus 3x. Okay, the remaining steps are same. Solve this too, so that you will perfect this method.